Okay, solving exponential and logarithmic equations. So we know how to solve an exponential equation if we can get a common base. So what's common between 4 and 32? 2. So 4 becomes 2 squared. 32 is 2 to the 5th, which is raised to the x plus 3. So we end up with 2 squared is equal to 2 to the power of what? 5x plus 15. Which means we can now say, well, that means that 5x plus 15 has to be the same as 2. Right? So if the bases are the same, then the exponents must be equal to each other. So 5x is negative 13, and x is negative 13 fifths. Okay. Now we could check that, although my smartboard's not behaving. But if you did 32 to the power of negative 30, well, what's negative 13 fifths? So plus 3 is 15 fifths. Be 32 to the 2 fifths, which is the 5th root of 32, which is 2 squared, which is 4. Okay, so it works. But what are we going to do if we have 3 is equal to 7 to the x plus 4? So why can't we use the same method? Yeah, no common base, right? We cannot express 3 and 7. We cannot express 3 and 7 with a common base. Solve it algebraically. Okay, so logs to the rescue. So here's how we now solve, right? You've been wondering this all along. The entire high school education has led up to this. But how do I solve for an unknown exponent? All we've been able to do is graph this. y1 is 3, y2, surely there must be a way. Okay, so here's the way. What you do is you take the log of both sides. Okay, now, I mean, log, it's just an operation, right? It's the operation that would say, give me the exponent I raised the base 10 to get the number 3. Right? And then give me the exponent I raised the base 10 to get 7 to the x plus 4. But the real power of logs is the power law. That power rule is the most important one. So this says that log 3 is equal to, so what do we do with the exponent? Put it in front. When we do that, since it's a binomial, we make sure that any exponent we're moving in front, if it's anything other than a single term, has to be in parentheses. So it's x plus 4 log 7. Now I say, hey, look, there's no more exponents here, right? We just have an equation. I can solve this. And it says express the answer as an exact value. So we have to realize that, okay. So, all right, how do I get the x by itself? Well, the first thing I'm going to do is expand this by multiplying the log 7 through the parentheses, right? So it's x log 7 plus 4 log 7, which means that x log 7, so I'm going to do a little swapping. Well, let's move this over there. So we'll get log 3 minus 4 log 7 is equal to x log 7. Now we haven't quite isolated the x. In order to do that, what have we got to do? Divide both sides by log 7. So then we can write x is equal to log 3 minus 4 log 7 all over log 7. So that's an exact value, right? Log 3 minus 4 log 7 over log 7. Now, we can play with that and write it in different forms. And we're going to do that because we never know what, on a multiple choice, what form the answer is going to take. So you're going to come up with an answer. Here's your answer. I got, oh, log 3 minus 4 log 7 over log 7. 100% sure that's right. As a matter of fact, I even worked out the decimal equivalents and it all worked. But none of these answers are in that form. So what's happening? What are they doing with this? So here's what we could do. So we'll put a box around this. So this could be one of the forms, right? That would be a common form of the answer. Okay, and we're going to go here, and let's split that up. So we could say x is equal to log 3 over log 7 minus 4 log 7 over log 7. Now, using the base change formula on this, how could we write log 3 over log 7? So log, what's the base? Of 3. So log base 7 of 3. What's 4 log 7 over log 7? Just 4. So here's another form the answer may take, right? Maybe it's written as log base 7 of 3 minus 4. Now, actually, if you worked this out and then worked this out, right? Like, so if you got this as an answer, you worked it out, got a decimal, and then said it's not that, but which of these are the same, you'd find that that's going to be the same, right? Just make sure you work them all out, because maybe 2 of them come to the same value, but one of them is just not a valid expression, right? Like, it's got that value, but that's not right. Okay, it's not that form. And what else could we do? We could do what? We could take this, so let's start over again, and we could write that as log 3 minus log 7 to the power of 4, so we could move the power up, over log 7. So why are we doing that? Well, because now you have the log of something minus the log of something. This can be written as a quotient, right? So it becomes the log of 3 divided by 7 to the 4th over log 7. Let's extend the page. Okay, so we're taking the exponent, moving it up. When we do that, we now have log minus. Remember, we can't do any of the logs of logs when you got a number sitting in front. So we got to get rid of that number. So it moves up here. Now we can do this. And base change formula, that would be the log base 7, right? What's in here, that's the log of the base. Log base 7 of 3 over 7 to the 4th. Okay, and that could be log base 7 of 3 over, and 7 to the 4th is 2,401. So it might just be worked out like that. So anything that's in the box. And again, if you solved it, this is what you got, and they were giving you different expressions, you could work out, you know, that's just a calculator thing, right? It's like bracket log 3 minus 4 log 7, bracket divided by log 7, hit enter, get a value. And then you could work out whatever they give you as answers and say, oh, it's the same as this one. Just make sure you work out all 4 if you're doing it that way, okay? Because you might have to decide, you know, yeah, this has the same value, but it's not really a valid way of doing it. Solve algebraically. Okay, so let's kick it up a notch. What if there's x's on both sides? So we do the same thing, right? We take the log of both sides. So the log of 2 to the 3x is equal to the log of 5 to the x minus 1. Now, generally speaking, I don't write that line. I go straight to the next line, right? And I just say basically, you know what, I'm taking the log of both sides, and then the power law allows me to just go 3x log 2 is equal to x minus 1 log 5. Okay, so sometimes I'll just go straight to the second line, right? So I've taken the log of both sides and I'm saving some time. I'm just going to move the powers out front. It's why I took the log of both sides. Okay, now the idea is we've got to get our x's on one side, get all the x's together, factor the x out, so you've just got x times something is equal to something, and then divide. Okay, make more sense if we actually just do it. So 3x log 2 is equal to x log 5 minus log 5. Okay, so we have to expand that set of brackets, right? It's the only way. So now we'll subtract x log 5 from both sides, right? This will get my x's over on the left-hand side. So I'll have 3x log 2 minus x log 5 is equal to negative log 5. And remember, everywhere you see log something, that's just a number. Right? Nothing magic about log. What's a logarithm? It's an exponent. Right? This is the exponent that you raise the base 10 to get the number 5. It's somewhere between 0 and 1. Okay? Now, factor the x out. Okay, so the idea is to isolate the x, and then divide both sides by what's multiplying the x. So x is negative log 5 over 3 log 2 minus log 5. Now, this could be written as log 8, right? So if you see 3 log 2, just think, it could be the log of 2 cubed, it could be log 8. But the idea here, I think, is to actually evaluate this, like just work it out on the calculator, right? So solve, yeah, it says express each answer as an exact value and also as a value rounded to the nearest 10. Okay, so here's your chance. What's this work out to? So give it a shot. I'm just getting a calculator because the on board one is not on board today. So work it out, because if you're going to mess it up, now is as good a time as any to mess up, right? 3 over 2. And also, I mean, this one works different because this is a TI-80 whatever, 3 plus. It's the old school one. Okay, we can answer to the nearest 10th. So everybody get your own answer, right? So I'd like you to disagree, and although most of us will have the same number. Okay, what'd you get? Okay. Or maybe it's, who's got a different answer? Nobody? Good. Y'all got negative 3.4? Okay. It's wrong, but y'all agree? No, it's right. If you did not get negative 3.4, then what you might have to watch out for is make sure you're using brackets. You need brackets around this. So you can go negative log 5. The negative is that little negative at the bottom in parentheses, right? Okay. Divided by bracket 3 log 2 minus log 5 with associated parentheses where needed. You got to close off the logs, right? Okay? So that's how you have to do it. Just make sure that when you're dividing by an expression on the bottom, the expression on the bottom needs to be in parentheses so that it's evaluated. This fraction bar says work this out, then do the division. Okay, so you got negative 3.4. Huzzah. Okay, what do we do here? We take the log of both sides. Okay, so the idea is I want to solve for an unknown exponent. I cannot get the bases the same, because obviously if we get the bases the same, it's trivial, right? I can't get the bases the same. This time I'm actually going to write it down. Okay, so I would like you to write the next line. What do you think the next line is? Or should be? Give it a shot, use pencil, have an eraser handy. If you're doing Math 31, have a big eraser handy. It doesn't have to be big in size. There's lots of eraser, trust me, I went through a lot of eraser. Okay, that's what it should be, right? Because you have the log of a product. You're going to mess this up. Now's a good time to mess it up, right? That's why I wanted you to do it on your own, so you could do it wrong if you're going to. It's the log of a product. 2 times 6 to the x minus 1. So you can't just go like x minus 1 log 12. Okay, but if you did, that's a good thing, right? Because now you won't do it again. You'll recognize, I can't do that, right? It's a product. So watch for this. I remember, I mentioned it the other day, right? You're gonna mess it up, okay? Until you start to realize, wait, it's a product, okay? Because I want you to mess it up now. It doesn't cost anything. Okay. So this is a product. So it's the log of this plus the log of this. So really intermediate, you could say it's log 2 plus log 6 to the x minus 1. Yeah, I like to cut to the chase. Just make sure this is in parentheses as well. Okay, so same deal, right? We're going to expand this. Get all our x's on one side, all of our non-x's on the other. Factor the x out of, and then divide both sides by that, just as we did above. And then we'll work it out on our calculator and get a value. Okay, so 2x log 3 is equal to log 2 plus x log 6 minus log 6. See which? Get the x's, so 2x log 3 minus x log 6 is equal to log 2 minus log 6. Factor the x out, 2 log 3 minus log 6. And then divide both sides by 2 log 3 minus log 6. So we've got log 2 minus log 6 over now we want a decimal too. We want to work it out. Now you could change it. You could go, that's the log of 2 over 6 or log 1/3, right? So I could say, hey, I don't want to work out log 2 minus log 6. I'll just do the log of 1/3. It should be the same, right? Okay. Or just type it in the way it sits there, right? Like, honestly, it's easier. And the bottom could be what? 9 over 6? Is that 3/2? You could have like the log of 1/3 over the log of 3/2. You can't do anything with that. When you have a log over a log, that doesn't simplify, right? But I'm going to try it that way. So log 1/3 divided by log 3/2. Okay. Have an answer. Nearest tenth. What do we get? You can verify it, right? Just go back up and go 3 to the 2 times that and 2 times 6 to the that. Okay, what is it? Negative 2.7. Okay, so I did log 1/3. That's a 9. So I did log 1/3 over log 3/2. Okay, don't do that because you'll mess one of these up, and it's like I did all this work and then then I got it wrong because and if it's numeric response, it's just wrong. Right? But I know that if that were numerical response on a test, you'd go back to the original before you walked out of that gym 45 minutes early and say, I'm going to spend just a little bit of time going through this, even though it's only 30% now. So it's really not that much of an exam. But thank God I walked in with an 80, or 90, or 95.
Mr. Aaron, are we having a bonus test?
Yes, you did sufficiently well on the Hume above your to earn
5%?
To earn a bonus.
Or a 7?
Don't push too much. I think it's probably 5. But
Let's go 6. Go 12.
Melchuk's the keeper of all of that. Go talk to her. Seriously, just say Anna sent us to bug you because he didn't know. Since a logarithm of a negative number does not exist, there are restrictions in the domain for equations involving logs which could possibly lead to extraneous roots. Right? We could solve this. Maybe we're solving a quadratic, and so we get a couple of answers, but we have to be aware that, wait a sec, I can't have a negative. So the first thing, state the domain for each of the following equations, then solve, and then check for extraneous roots. Okay? Obviously on the diploma you can't really be asked to do that, but they will give you the extraneous roots of solutions. This thing's been leaping all over the place. They'll give you extraneous roots for solutions, so you got to make sure that, hey. And one of the big things when you're doing the diploma is, as you do a question, look at the answers and just say, why is that answer there? Like, why do they have a negative 2? I got a 2. Why do they have a negative 2? And you might just, oh, you'd have a negative 2 if there was a reflection. Oh, wait, there is a reflection, and my 2 really should be a negative 2, right? Or, you know, just say, what kind of mistake would you have to make in order to get those answers? And maybe that's not your first time through it. Maybe you go through it the first time, and then the second time you're looking more carefully. And so why are these other answers there? Okay, so what do we know? X plus 1. What's x plus 1 got to be? It's got to be greater than 0, right? Okay, take the log of 0, right? 9 to the what is 0. You can't do that. Okay, so then x has to be what? So x has to be greater than negative 1. Okay? So if we solve this, we get any answers that are less than negative 1, we reject them. But we show them, right? So for me, you're showing it, and then you're, no, yep, doesn't work because of that. Okay, how do we solve this? Take the log of both, no, it's already got a log. Change it into what form? Exponential form, right? So it's 9 to the what? To the 1/2 is equal to x plus 1. Okay, so 9 to the 1/2. What's 9 to the 1/2? 3. What's x? I'm going to go with positive 2, but just, let's not be negative. You have no school tomorrow. Be positive. Some actual, what, 16% of you have a blood type that's B positive? No, I don't know. What's the percentage of B positives in the world? Because they're doing bio.
I don't know, it's pretty low.
Yeah, it's low.
Well,
What's the most common? Like O positive?
O negative.
O negative is the most common? They're the universal donor. But are they the most common?
No.
Yeah,
No.
AB, whatever.
AB is the universal receiver.
Yeah,
But
AB.
the most common is O.
Oh, I know O is, but is it O positive or O negative?
It's O negative, I'm pretty sure.
Yeah, okay.
Yeah, O
So,
negative.
my kid's O negative, so they always like her because it's the universal donor, right? Anyways, what do we do here? Log base x. What do we know about x? Yeah. So the base has to be greater than 0. Okay, how do we solve this? Okay, so x squared is 16. X is plus or minus 4. Cross out the minus 4. Because we know that x, the base, has to be greater than 0. Okay, you cannot have a negative base. You can have b negative, but negative base. Smartboard is just not behaving today. It's a recalcitrant smartboard. Okay, so x squared minus 8 has to be greater than 0. So if we think about that, let's do that. So x squared minus 8 is greater than 0. So x squared minus 8, it's a quadratic that's moved down 8 units. Its x-intercepts are negative root 8 and positive root 8. So it's positive, excuse me, it's positive over here and over here, but this is an x, so we know that x must be greater than 0, so then we're going to go with greater than root 8. Okay, so you want the more restrictive restriction, right? So as far as this is concerned, you could have a negative value for x, right? As long as it was greater than negative root 8. So our restriction is that x is going to be greater than 2 root 2. Okay, good. Now we can solve, right? And that's because of this, because here x has to be greater than 0. It's got to be positive. If there was a negative there, then it would have to be negative, right? And we'd be going this way instead. All right. How do we solve this? Oh, well, so if log base 3 of A is equal to log base 3 of B, what can we say about A and B? They must be equal to each other. So these two expressions must be equal to one another. So x squared minus 8 must be equal to 2x. With this proviso, right? So because it's a log expression, we know that the x on the right-hand side has got to be greater than 0, on the left-hand side it's got to be less than or greater than. So we got x squared minus 2x minus 8 is equal to 0. I think that factors, right? Show it, and then blow it off, right? So show the solution. I'm solving this. Here's the solution. X is negative 2. Oh, it doesn't matter. Yep.
Would it be correct to assume that if you put 3 to the power of log 3
3. You could go 3 to the power of log base 3 2x is equal to 3 to the power of log base 3x squared minus 8. Right? You could put this to exponential formula. Like 3 to this power is equal, and when you're doing a 3 to a base 3 log, it just becomes this.
Yeah.
Right? So, yeah, you could go 3 to the power of log base 3, so that's this guy, of 2x is equal to 3 to the power of log base 3. It's kind of actually what you do. We just sort of said, look, they got to be the same, right? But that's an actual way to do it. Because then this simplifies and becomes 2x, and this becomes x squared minus 8. You can skip that step. You don't need, right? Because you're saying log base 3 of something is log base 3 of some other thing, so those things have to be equal. It's like saying 2 to the x is equal to 2 to the 5x plus 1. You can just equate. I mean, what are you actually doing when you're doing that? You're really taking log both sides, moving the thing, and then dividing out the log 2. So, all right, log x minus log 3.5 is log 2. If I could get a single log expression, so what do we do to get a single log expression? Oh wait, first off, what? X has to be greater than 0, right? So note your restriction. Okay, so what's this work out to? What's the next line?
2 equals x over.
Yeah, x over 3.5 equals 2, right? If the log of this is equal to the log of that, then this and that must be the same things. Okay. So x over 3.5 is equal to 2, and x is equal to 7. So if you go log 7 minus log 3.5, it would be the same as log 2. I hate this thing. All right, just a few more. Log base 2 of x plus log base 2 of x plus 4 is equal to 3. So x has to be what? X is greater than 0, and x has to be what? So what are we looking for? X must be 0, right? You have to be more restrictive. Negative 3 is going to work fine in that expression, but it will not work at all in the other expression. So if we solve this, get anything less than 0, we reject that. Okay? Restrictions are always on the original. Okay, what do we do when we add? Okay, so the sum of logs is the log of the product. So log base 2 of what? X squared plus 4x is equal to 3. What's next? I don't know how to do that. change it to exponential form, right? So it becomes 2 cubed. 2 to the 3 is equal to, oh, okay. So we get x squared plus 4x minus 8 is equal to 0. Then we factor it, except it doesn't factor because somebody, like, seriously, you're going to make us do the quadratic formula. Okay, so we got to pull out the quadratic formula, right? X is equal to negative 4 plus or minus the square root of 4 squared. Everybody knows to be singing to the tune of Pop Goes the Weasel. 50 years from now, you'll still remember that. Sing it to some grandchild. X is equal to negative b. So they don't understand English anyways at that point.
What? You think it's gonna be like Mandarin or something?
No, I mean when they're a young child, they're not gonna know the difference between you singing "Round and Round the Mulberry Bush," the monkey chased the weasel, or X is equal to negative b plus or minus. The kid's gonna walk into high school and say, "I know this from it's a nursery rhyme." X is equal to negative b plus or minus. It never made any sense until now. And now it's the quadratic formula.
Throw in second. They'll probably learn the same thing.
Oh, man, keep going. Negative 4 plus or minus, what is that? 16? 4 root 3? X is equal to negative 2 plus or minus 2 root 3. Like it jumps to another page there. If I try and go back, maybe it'll be. It's like it's locked on to something.
You turn it off and on.
Yeah, well, we'd be waiting 10 minutes, so I'd just soon suffer with this for now. I'm just going to power the whole thing off for the weekend, right? Okay, so we've got x is equal to negative 2 plus 2 root 3, and we've got x is equal to negative 2 minus 2 root 3, but that strikes me as being negative, and we said x has to be greater than 0. So we can cross that off. Right, and if you like, you can say, here's my solution set. Right, not going to touch the board. I'm just going to move it up by itself. All right, what do we do? Okay, yeah, first there's restrictions, right? So x is greater than 1, x is greater than 1/3. So what's it going to be? Greater than 1, okay? So here, x is greater than 1/3, x is greater than 1. Well, you know, I mean, you can verify these graphically too, right? You can just graph them and solve them and just say, hey, there's 2 solutions, and I thought there was only 1. Oh, wait, maybe that wasn't a restricted value. Or I have 2 solutions, but the graph is only showing 1. Oh, yeah, wait, it can't be. Okay, now what? So if I had a single log on each side, what do? We just drop the log 3, right? So can I get a single log on the right side?
Yeah.
Okay, how? Multiply.
Yeah.
Here, I'll do the formal, let's get rid of the logs, right? We've just been dropping them. So what I'm going to do is I'm going to take 3 and raise it to each side. Which means this, 3 to the log 3 of 3x minus 1 is just 3x minus 1, and this guy's 5x minus 5. Okay. So that's how you get rid of the log, right? I mean, legit, you could just look at it and say these two guys are equal to each other. But if you want some mathematical, what allows you to do that? I'm going to take 3 and raise it to each side. As long as I do the same thing to both sides, it stays equal, right? Okay, what do we get? 2x is 4. X is 2. Okay, does that match our, yeah, it's good, right? Meets the restriction. So you end up with log 3 of 6 minus 1, which is 5. Log 3, 5 is equal to log 3, 1 plus log 3, 5. But log 3, 1 is 0. So you got log 3, 5 is log 3, 5. Check. Whoa, keep going. Okay, so what's x? Greater than 0 or... So greater than 3 wins out, right? It's the more restrictive restriction. So now what? Change the right side. How would you like to change the right side?
Put the 1/2 as an exponent.
Put the 1/2 as an exponent. Okay. So log 2x is 2 plus log 2 1/2. Okay, now what?
Subtract log 2 x minus 3 to the 1/2 from each side.
Yeah, so if we get our logs on one side, right, and since they're just log now, right, there's not a 1/2 log, not a 5 log, so I'm going to do log 2x minus log base 2, you know what, I'm just going to write that as the square root of x minus 3. Okay, because we can, right, why not? Oh, and I've got log minus log, so what am I doing? Yeah, dividing. So we combine that into the quotient. And how do we do this? I can never do these logs. Let's unlog. Let's change it to a different form, like exponential, right? So yeah, let's lose the logs, right? So 2 to the 2 is equal to this. Or x over the root of x minus 3 is equal to 4, right? So 2 to the 2. Change it from logarithmic form. You can't work with that. I can't solve that. Change it to exponential form. Oh, okay. So then x is equal to 4 root x minus 3. All right, how do we solve that? It's radical. So what do we do to solve a radical equation? Yeah, you get rid of the radical. So we got rid of the log by changing it to exponential form. We'll get rid of the radical by squaring both sides. So x squared will equal 16 times x minus 3. So that's 16x minus 48. And now it's quadratic. And 48 and 16, what do we got?
4.
That'll work. Both minuses, right? Because got a positive 48. Okay, so x is equal to 12 or x is equal to 4. Now, does any of that violate our, what do we say? X had to be greater than 3, right? Okay, so 4 is greater than 3. So x consists of the set of numbers 4 and 12. Okay, and if we could see the thing, move this back up. So you're saying log base 2 of 4, which is 2, and 4 minus 3 is 1, so log base 2 of 1 is 0. So we've got 2 is equal to 2. Works. Got log base 2 of 12, 12 minus 3 is 9. The square root of 9 is 3. This is log base 2 of 3. So it's 2 plus log base 2 of 3. But 2 is log base 2 of 4. So we got log base 2 of 4 plus log base 2 of 3, which is log base 2 of 12, which is the 12 that's good. Works. Right? You're all going, what the hell is he babbling on about? Okay? So if you put a 12 in there, you get a 9. But the half, so it's log base 2 of 9 to the half. 9 to the half is 3. This is log base 2 of 3. 2 is log base 2 of 4. Log base 2 of 4 plus log base 2 of 3 is log base 2 of 4 times 3, which is 12, and that's the 12 that we stuck there. Okay? Do it on your calculator. It works. Wow, now what? Okay, what's the restriction? So greater than 3 or greater than negative 1. Okay, what do we want to do? Well, let's get rid of the 2. How do we get rid of the 2? Move it. Move it where? Move it up here. Let's, at the same time, subtract this and set it equal to that. So, we don't want the 2 in front because the laws of logs don't work when you have a number in front of the word log. But the laws of logs allow you to get rid of the number in front. So now this just becomes log base 9 of this squared, so x squared minus 6x plus 9 over, because it's minus, over x plus 1, and that's a log, is equal to 1. How do we solve these things again? I can never remember. I can't do this log stuff, but I'm pretty good with exponents, all right? So what do we write? 9 to the 1. So x squared minus 6x plus 9 over x plus 1 is equal to 9 to the 1, or 9. Right? So 9 to the power of 1 is equal to this expression. Multiply both sides by x plus 1. X squared minus 6x plus 9 is equal to 9x plus 9. X squared minus 15x is 0. X is 0. Or 15. What do we say? It's going to be greater than 3? Is that true? What do we got? 15 minus 3 is 12. 12 squared is 144. That's a log of 144. 15 is 16. Log base 9 of 16. And then that would be log base 9 of 9. And 9 times 16 is 3. Yeah, it works. I checked it. It works. Okay. So you could graph that. If you're going to solve it graphically, just make sure your window includes 15. Right? It doesn't need to go below 0 because you could go to negative 1 because you will see the right-hand side will exist from negative 1 on. Not including negative 1. I think we're almost done. Last one. Log of x squared. That's not the log of x squared. That's the log of x quantity squared. We do not get to write that as 2 times the log of x. Okay? Without the parentheses there, if it were the log of x squared, then we could write it as 2 log x. But we can write this how? So we've got the log of x squared minus the log of x minus 12 is equal to 0. So we have something squared minus that same something minus 12. So it's a quadratic, right? So what are we going to do? We're going to let a equal log x. And we're going to solve a squared minus a minus 12 is equal to 0. So that's a minus 4, a plus 3. So a is equal to 4. A is equal to negative 3. Oh, we should have said here, right, what, x greater than 0. Don't reject this right away, though, right? Because it's x that's greater than 0. It's not a. Okay? So now we got to say, I'm just going to kick up here. So now what do I say? 4 is equal to log x. So what's x equal to? I don't get fancy. What's the base? So x is 10,000? Okay, that's good. It's greater than 0, right? Okay, or what? Negative 3 is log x. So what's x? Let's just go with 1 over 1,000. Okay. So and those are both valid, right? So this would be the inverse of 1 over 1,000. This would be log 1,000. That would be the log of 1/1,000. What's the log of? So that'd be negative 3 squared. Whatever. I'm sure they work. Did anything violate? No, x, that's greater than 0, right? So is that. Yeah. So, I mean, the log of 10,000 is 4, right? So 4 squared is 16. The log of 1 over 10,000 is negative 4. That would be 16 minus 4, which is 12. Okay, so this guy works. The log of 1/1,000 is negative 3. Negative 3 squared is 9. The log of this would be 1,000. It'd be 3, so it'd be 9 plus 3, 12. That works too. They work. Look at that, we're ahead. Just going to go on forever.